Hello and welcome to today's class. Let's look at the study of gravitational potential and escape velocity. So in this topic here, there are two terms there. The first one is called gravitational potential and the second one is called escape velocity. We'll look at these two concepts one after the other. Let's start with the first one there called gravitational potential. Let's discuss gravitational potential. Alright. So let's start with the first one called gravitational potential. By definition, gravitational potential at any point on the Earth's surface is the work done in moving a unit mass from infinity to that point. So when it comes to gravitational potential, it's simply a work done that is required to move a unit mass from infinity to that point. That's basically gravitational potential. By definition is represented by V. Note that gravitational potential is represented by V. Mathematically, gravitational potential, that V, is equal to the product of gravitational constant and mass of Earth divided by the radius of Earth. So note that, mass. Please note that the formula for gravitational potential is V equal to what? Gm over R. G there is your gravitational universal gravitational constant. Your m there is your mass, while your R is your distance. It becomes the mathematical expression for gravitational potential. And the SI unit, for this is kilogram, it's joule per kilogram. Joule per kilogram. So the unit for gravitational potential is given as joule per kilogram. How do I get joule per kilogram as the SI unit to this? It's easy. Let me show you how I got the SI unit to this as being joule per kilogram. We said V is of course Gm over R. G is called universal gravitational constant and the unit there is given as Newton meter square over kilogram square. That's for G alone, times mass is simply the mass, your mass, that's a kilogram. I have this all over R. R is in meters. All right, from here it's clear that K will cancel one K. I'll have a K left here, kilogram per se. So I'll have Newton meter square over kilogram left for the numerator. All over what there? All over M. I can write this as saying that V will be equal to, or perhaps just ignore V. So I can work this as Newton meter square over kilogram divided by what? Divided by M. Work on this. I'll have that Newton meter square over kilogram. We said change this to times. Now becomes times. I'll have invert 1 over M. What do you observe? This M will cancel 1 M here. I'll have 1 M left. So I'm having what left? Newton meters over kilogram. By the way, there is one parameter that signifies Newton meters. For Newton, it's force. For meters, is distance. So a kind of formula signifies force times distance, and that's what? Your work done. Work done signifies what? Or work done expression is what? Force times distance. So I'm saying Nm. Nm is what? Force times distance. That's work done. And work done is measured in what? In joules. In joules, right? So I can say that V, this V can be expressed as what? Newton meter, that's your joules, per over what? Over kilogram. Over kilogram. So I'm saying that V is what? Joule per kilogram. That's how I got the SI unit to V as joule per kilogram, as I showed you earlier now. So this is basically the concept behind gravitational potential. Let's take a sample problem on this and explain better. Example on this. Example on this. Let's take example on this, please. Example here says, find the gravitational potential at the Earth center. Find the gravitational potential at the Earth center. Let us first. What we know is that gravitational potential is equal to V, equal to what? G M over R. By the word, find the gravitational potential at the Earth center. It means that my mass here becomes mass of Earth. My R here becomes what? The radius of Earth. And we know that G itself is 6.69 or so. From here, we know that this G is 6.67 times 10 to the power what? Minus 11, right? That's Newton meter square per kilogram. And we know that ME, mass of the Earth, which is what? 5.98 times 10 to the power 24, and also RE, that's the radius of Earth, is 6.38 times 10 to the power 4. That's the radius of the Earth. Power 6, please. It's power 6. So these values are constant. So to get V is easy here. To get gravitational potential, V should be equal to G. What's G? 6.67 times 10 to the power what? 11 minus 11. That's G. Next that's there. ME. ME is of course 5.98 times 10 to the power 24 all over what's RE? That's 6.38 times 10 to the power 6. Have this. So what's V? To save time, press calculator straightforward. That V is equal to 625,181.82. V we said is what? Joule per kilogram. So I have joule per kilogram. This becomes my answer to this particular question. So know that G is constant. ME, mass of Earth, is a constant value. RE, that's radius of Earth, is also constant value. That's here in meters, here in kilogram. Very important, please. This is your answer to that question, please. This is how you solve particular problem when it comes to gravitational potential. Let's look at the next concept called escape velocity. Let's look at next concept called the escape velocity. Let's look at escape, the escape velocity. All right, please it's important to know that escape velocity is represented by VE, escape velocity. By definition, escape velocity is the minimum velocity required for an object to just surpass, in bracket, escape or leave, close the bracket, the gravitational influence or field of an astronomical body, in brackets, that is Earth, permanently. So that's basically the definition for escape velocity: the ability of a body to surpass or escape a gravitational influence or an astronomical body permanently is said to be an escape velocity. That's VE. I should have gone ahead to give you the formula for VE, but yet we have to do a proving on how to get the mathematical expression. So let's get mathematical expression for VE. To get the formula for VE, we'll draw a diagram. Let's draw a diagram. I'll draw a circle this way. All right, I have this way. Here is my mass of Earth, and here's my mass. Here to here is called my R, distance. All right. Now, first things first, to get my VE formula, I'll have to apply the concept of Newton's law of universal gravitation. Now, the force of attraction here, F, is equal to G M E over R. I have ME over R. So the force of attraction between these two masses is there, and the distance between them over R square per se, please. R square. So I'm applying the concept of universal gravitation to get this. Now from here, for me now, the next task from here is that for this mass of Earth to move out, there should be the work done will be done to move this mass from here to outside, like to escape the Earth, right? So the maximum work that must be done for this mass to move out from this Earth. Although for me now, I have to work on the work done, because a work must be carried out for this mass to move. For the mass to move, like the work done is moving the mass of the Earth. So I'm saying that work done, from work done, because from work done, that work done is what? Force times what? Distance. In this case, my force is what? G ME over R squared. That's my force. In this case, my distance D is of course R. You said R is your distance. Put these two here inside work done. I'll have that work done, W, is equal to F. What's F? G ME over R squared. That's your force. Times, what's D? That's R, times R. What you observe here, this will cancel this one. I have one of it left. So the work done to move the mass will be given as G ME over R. This is the work done, like to move the mass, right? So, and here's the concept: when moving the mass, when work done is carried out, there's a process of you moving. You have to, for the mass to move away from the Earth, a movement will occur, and that will lead us to what's it called? That will take us to the concept of kinetic energy. Yes, kinetic energy is simply an energy that is possessed when work is done through motion. So here's the concept: for this work to be done, a movement will take place. So that will take us towards the concept of kinetic energy, right? Now for me now, from kinetic energy, so in this here's the concept: I'll be equating kinetic energy, Ke, with what? With work done. And we know that kinetic energy, Ke, is what? Half mass velocity square equal to what's work done? That's G M E over R. I just explained why we equate Ke with a work done. All right, from here, 1 times mv square is what? Mv square over these 2 equal to GMME over R. What do you observe? If I have the same expression at the same level, numerator, they can cancel out. So this m can cancel this m. So I'll have that v square over 2 is equal to GME, that's GME over R. Next task here, I'll have to multiply v square times R. That gives v square R equal to 2 times GME, that's 2 GME, mass of Earth. Now let's task here. Now in this case now, my v here will not be just velocity, because what? My sk velocity, that's ve, please, ve. So it becomes a ve, not just v, becomes a v, becomes ve. I'll try to make ve subject here, divide by r. So this one will cancel this. I'll have that ve squared is equal to what? 2g me over r. All right, I have this. Next task here is that I will impute this here. I will replace small r as being equal to capital R. Why? We said for the object to surpass the Earth, right? So of course, if here to here, this R here are surpassing the Earth here, but if I'm to consider this radius here, it will be capital R. This is the radius of Earth, capital R. So for this mass now, this radius here are not a supersede, that's capital R. Once it's supersede, there is small r. So I have to change it to capital R. So I'm saying that small r should be capital R. It means anywhere I see small r, I'll replace that what? As a capital R. All right, so from there I'll have that ve squared, should I clean? Okay, clean this part here. I'll have that ve squared is equal to 2GME over not r, not small r now, but what? A capital R. All right, I have this here. My next procedure here is to recall one concept. I have to recall the relationship between gravitational constant and acceleration due to gravity, that we said G should be equal to what? GME over R. This video has been done. So we already dealt with gravitational field in general. I'll look at all these concepts in our last class. We dealt with gravitational field, we did the derivation of a lot of stuff. So this one here, I did a video on how to prove the formula between relationship between gravitational constant and acceleration of gravity. So this is the formula here. So here's the concept now. I'll make ME subject here. Making ME subject, I'll have that GME equal to what? GR. Make ME subject. ME should be equal to what? GR over capital G. Yeah. From here now, anywhere I see ME here, I'll put what? GR over G. So from here, proceeding from here. All right, let me just clean this part. Proceeding from there. Sorry. There should be a square here, please. A square. square, please. This your relationship between acceleration to the gravity and universal gravitational constant. All right. Now let's stop, please. From here, I'll have that V E squared is equal to 2. Then G, what's ME? ME is what? Times G R squared over capital G. That's ME, right? All over R. So in this case now, our R here should not be small r, should not be capital R, because we have already established that concept here. So capital R here, capital R here. Next up, divided by R, I have R. Next task here, I'll have that V E squared is equal to 2G times G R squared over over G. This division comes to times and invert 1 over R. This G will cancel this G. This R will cancel 1 out of it. I'll left with 1 R. So I'm saying that VE now squared is equal to 2G and then R. To get the value of VE now, which signifies escape velocity, should be equal to square root of 2GR. This becomes the formula for calculating the escape velocity in the body. This calculates for this formula for calculating escape velocity. Now, here's the concept. This G is a constant. That's 9.81. This R is called radius of Earth, also a constant. So it means that we can get a value for VE. So if I know all this stuff, definitely I can get a value for VE. Let's get VE. What will be VE? From here, VE will be equal to the square root of 2 times 9.81, that's your small g, times what's R? I gave you R earlier now. I said R is called radius of Earth and is given as 6.38. All right, times 10 to the power 6. That's your radius of Earth. So multiply this together. I shall have that VE is equal to, my answer should give me about 11,200 meter per second. This is my value for escape velocity, right? So this is the formula for escape velocity, and this is the value for escape velocity. This is like the concept behind escape velocity and gravitational potential. All right, do well to, if you like this video, do well to like the, if you enjoy this class, do well to like the video, share the video to your friends and classmates, and leave a comment. Also do well to join our channel member to get exclusive content such as this. Once you join channel member, there's some content that will not be allowed for students to watch. So those are membership that can have access to the videos. So do well to join the channel membership, very important. And also do well to visit my website to get more of these courses at www.ghanarecord.com. In my website there, you get access to close to different topics: physics, chemistry, mathematics, organic chemistry, and other science courses there. You can buy the course there or get access to it. And once you get access to the courses, it's a lifetime access, right? So that's how it works there. So this like the concept behind gravitational potential, that's V, and escape velocity, VE. All right, see you in our next class.